Hello, this lesson is about Newton's third law of motion. Let's understand it and then go through some examples. By definition, Newton's third law of motion tells us that whenever one body exerts a force on a second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that it exerts. In other words, that's the action and reaction law. For example, if you press your finger on the wall, you're exerting a force on the wall and the wall is exerting a force on your finger. The forces are equal in magnitude and opposite in direction. Another example is the tide system in our planet. So the sun and the moon, they exert forces, the gravitational forces pulling the water body from our planet in one direction, and as a reaction the water body in our planet exerts a force in the opposite direction. Alright, so let's practice a little bit. So imagine you have a 60-kilogram acrobat in the middle of a 20-meter long tightrope. The center of the rope dropped 30 centimeters in relation to the ends that are attached to fixed supports. So what is the tension in each half of the rope? So my first advice for problems like this is to draw the problem. And it would be something like this. Okay, so let's think about it. So we have the acrobat in the middle and we have his weight force. And as a reaction, we have the tension on both sides of the tightrope. So this system is in equilibrium. Nothing else is moving here, there is no acceleration. So because it's in equilibrium, we know that the force pointing down has to be the same as the summation of the forces pointing up. In this case here, the force pointing down is the weight of the acrobat, which is mg. And the forces pointing up are the tensions in this direction. So it's T1 sine of the angle 1 plus T2 sine of the angle 2. We also note that because he's in the middle of the tightrope, these are symmetrical forces, so we can add them up and find this equation here. That 2t, the traction force on the tightrope, times the sine of this angle equals mg. So we now need to find this angle here. And to find it, let's use a little bit of trigonometry. If you take a look on this left part here, we have a right triangle and we can find the length of the tightrope on this side applying the Pythagoras theorem, and it gives us a length of 10.0045 meters. Now that we have all these values here, we can find this angle. We know that the sine of this angle is actually the opposite side divided by this length. So we have the sine of this angle is approximately 0.03. Now we have everything here we need to find the traction force. So from equation 2 in equation 1, we just add the values and then we can find a tension of 9,800 newtons on each side of the tightrope. Okay, so let's put your knowledge to the test. Think about this statement here. I exert a force on a car, and the car also exerts an equal and opposite force on me by Newton's third law. Hence, I should not be able to move the car ever. So, is it true? We know, of course, that if we exert a certain amount of force on a car, it will definitely move. So what's happening here? Can you explain why the car moves? Is the Newton's third law wrong? What's happening? Think about all the forces that are being applied on the system and write in the comment section your answer.
We hope you liked this video. Press subscribe, thumbs up, and stay geekly.